What I'm going to explain to you today is a brief description of what actually happened on the ground from a physical perspective. You've heard plenty from, or you can hear plenty on this site from people who were there and witnessed it firsthand. This is a little bit more of an antiseptic or physical approach to what's going on, so you can understand the energy and the way the bomb blast actually worked. Both the bombs, the Fat Man bomb dropped over Nagasaki on August 9th, and the Little Boy bomb dropped over Hiroshima 3 days before that, had comparable amounts of energy when they were produced in terms of blast, and we'll get to that in detail. But what people experienced on the ground, completely unexpected, when both bombs went off, was an instantaneous fireball first. That fireball had expanded to over 60 meters across in less than a second, and rapidly expanded from that point on because it's going the speed of light. So that's something you couldn't even perceive in terms of the speed that it's expanding. The blast shattered windows up to 16 and even more kilometers away from ground zero where the bomb was detonated. And it could be felt, the sort of vibrations from that explosion could be felt upwards of 60 kilometers away from the hypocenter. Fires were started, obviously, immediately at ground zero because the temperature rocketed to the temperature of the surface of the sun within a matter of fractions of a second. And fires, anything flammable, ignited up to about 3 kilometers away from the hypocenter. Anything that was within a kilometer or a little bit less of the hypocenter was immediately vaporized because those temperatures are so high that they'll turn anything into a gas. Fundamentally, the bomb leveled several square kilometers of the city, depending on the city, and we'll talk more about that a little bit later. And the destruction was felt instantaneously, ultimately resulting in over 100,000 deaths in Hiroshima and close to that number in Nagasaki. The bomb itself, in detail, over both cities, underwent the same process. So initially, when the nuclear reactions are started in the bomb, when it's detonated about 2,000 feet above the surface of the Earth, it initiates a fireball. That fireball spreads in a sphere away from that detonation center, which is, like I said, several thousand feet above the ground. That sends out a shock wave and a heat wave in a sphere. So obviously anything above it isn't affected, but everything on the ground is seriously affected by the energy that's produced by the bomb. That expansion of the sphere of both blast and heat, and we'll talk about what those mean in a second, is so fast that it forces most of the air above or around the bomb away. And so what you've done is you've produced a vacuum. And when you produce a vacuum, you have to unproduce a vacuum. And that means that you've pushed all this air out from the blast, and then all of a sudden this air is going to come rushing back in to fill the vacuum, and it's going to rush right back into the point where the bomb was detonated, and all that air is going to run into itself, and it's going to be forced up because it has to go somewhere. And that's what produces the mushroom cloud that you see in any kind of atomic weapon test or atomic weapon detonation. And so that mushroom cloud builds and builds over the ensuing time after the bomb has been dropped, but it is directly the result of the blast pushing out and then sucking back in. So the energy from an atomic weapon is dissipated, or it's produced in 3 ways, and this is how it differs from a conventional weapon. Like most weapons, it produces heat and it produces blast. It was about 50% heat, these are 2 atomic weapons in 1945, 50% heat and 35% blast. But it also produces radiation energy, and that's how it differs from a conventional bomb. Both bombs produced a total energy equivalent to about 20 kilotons worth of TNT, so that's 20,000 tons of TNT if you could have found a way to detonate it all in one place and all simultaneously, which would be virtually impossible. So let's go through each of those kinds of energy to get a grip on what those mean. So, like I said, the first and the bulk of the energy that comes out of the bomb is heat, and it's virtually instantaneous that it's produced from those fission reactions. And you'll reach temperatures of thousands of degrees at the hypocenter, at the location on the ground immediately below the detonation of the bomb. Basically the equivalent temperatures to the surface of the sun at first. That will result in an incredible amount of damage that is heat generated. Anything that is flammable within a few kilometers is going to go up in flames. It's going to have the capacity to melt material that normally you never run into melted. So ceramic tiles that are classic architectural pieces of Japanese houses, for instance, they actually started to boil. And you have to have a temperature of about 1800 degrees Celsius for at least 4 seconds exposed to a ceramic tile for it to boil and form these bubbles. And so you can see in this picture that any of the tile that was exposed to the heat rays, the heat blast basically, has gone to this bubbly texture, and that's evidence of the high temperatures that were reached. Anything that was meltable, bricks, ceramic, glass, metal, would often get fused together. So within a few kilometers of the center of the bomb's detonation, you can find evidence of teacups melted together, of glass bottles melted together. There are many cases where you can find a fusion of ceramics and glass and human bone in some cases. Anything organic, bodies, animals, humans that are located within about a kilometer or so of ground zero were going to be vaporized in the process with no evidence left, not a trace of them left behind. There are many examples where people who went to Nagasaki or Hiroshima afterward could find evidence of where someone was sitting, for instance, and they're no longer there. And you could trace the outline, a shadow basically left behind from that vaporization process. And there's another picture that we can show you here of an actual outline of a human and a ladder that he was presumably working with when he was also vaporized. If you go a little further away from the hypocenter, it's not hot enough to vaporize organic material. Instead, it's ignited, so it goes up in flames. And within upwards of 3 kilometers or even 4 kilometers, anything that was flammable and black would actually get ignited. So obviously anyone located near the center of the detonation was going to, and who was not vaporized, was charred beyond recognition. So bodies were unrecognizable. It was very difficult to identify which people had actually been killed in the bombing. And after the bombing, those who did survive were often burned. Upwards of 50% or more of their body's surface area was burned. And so it made it very hard to care for people, given that burns require such intensive treatment for people to survive. The second form of energy that's released from the bomb is blast energy. Blast is literally wind, going several hundred miles an hour, so hurricane force winds. And that will tear buildings apart, it will tear objects apart, it will tear people and animals apart as well if they're located near the hypocenter. So upwards of 10 kilometers, sometimes even out a little further, glass was shattered significantly from that blast, so from the high pressure winds that were generated. Nagasaki had a focused version of the blast, which I'll explain in a second. It was amplified by the topography or the mountainous region around Nagasaki. And you'll be able to notice in pictures that the objects are shattered and pulverized to much smaller particles, much smaller pieces as a result of that focused blast. Another place where you can see the evidence of the power of the blast is a Torii Gate that's located relatively near the hypocenter. It's a concrete Torii Gate, so it was poured from molded concrete. And a Torii Gate has 2 parallel pieces to it at the top, and it's only half a Torii Gate left standing. And the half that is remaining standing has been canted, sort of forced away by the blast. So you have to imagine a blast being strong enough, coupled with heat to melt the concrete a little so it's ductile, so it could move a little, to actually force that Torii Gate out of alignment despite it being made out of concrete. And the other thing you can see along it as well is that all the engravings, the carving in the sides of the concrete have been melted away by the heat. So that Torii Gate by itself illustrates the effect of the blast, which knocked it out of alignment and knocked half of it down, and then the heat that melted away the surface that was facing the bomb.
One of the other things that happens because as a result of this blast is that all this shattered glass gets thrown out with the wind and then to some extent brought back by the winds. And so people were seriously affected by flying pieces of glass. It would get into people's eyes, into their face, cut tendons. It made some very critical injuries people had a hard time recovering from as a result of the flying glass. In many cases, it's killed them outright. And this is a photo of a concrete wall that has been peppered with flying pieces of glass, to just give you some sense of how much glass was flying through the air during the actual explosion. Many people died from objects getting thrown at them, of getting buried under collapsed buildings. All of that's related to the production of the blast energy that comes from the bomb.
Third form of energy that's produced by the bomb is radiation. And again, this is what distinguishes atomic weapons from conventional weapons, in addition to their magnitude, is the fact that it produces radiation. Radiation is a sort of a shortened term for something called ionizing radiation. Ionizing radiation simply means that you've produced enough energy that an atom, which consists of a nucleus and electrons around it, can have electrons pulled off it. So the process of ionization is literally yanking an electron off of an atom. Now, that doesn't necessarily do much harm, but if you happen to affect an organism's DNA by doing that, by destabilizing one of the atoms, you can render that DNA to have a different structure. That may, again, not result in any effects on the organism, but it may also result in a mutation that could lead to all sorts of health issues, particularly cancer, and even in genetic mutations that can be transferred down from generation to generation. So as a result of this radiation effect, which is, you can't see it, you can't feel it, it made this bomb feel very different to many people afterwards. Those who survived, who perhaps were unscathed by the bomb's blast or heat, had escaped the fire, had escaped getting hit by the pressure of the bomb. Some of them got sick. Some of them had problems with their hair falling out, for instance. If they survived the bomb, they had a pretty high chance of actually losing their hair as a result of radiation sickness. That's what they were ultimately experiencing, but no one knew how to diagnose this at the time because it was completely unexpected in the weapon. People were exposed to radiation in two big ways. The first was initially, if they were exposed to the initial blast, a lot of neutrons and other radiation particles are produced, and that's, of course, can cause all sorts of damage. And if it's a high enough dose, people, it was fatal, and they would die immediately. But if they were exposed to a smaller level of radiation, they were likely to survive and experience radiation sickness. The second way they could get exposed to radiation was that the dust from the blast, from pulverizing all these buildings and smacking the ground so hard, would get remobilized and brought up into the mushroom cloud. And then when it started to rain shortly after the bombs were set off, and that rain picks up the dust that's in the air and brings it down onto the ground and concentrates it. And it contains a lot of atoms that have become radioactive. So this is a secondary form of radiation that people were exposed to. It's called fallout. In the case of when it's brought down with rain, it was called black rain. The long-term effects from radiation are genetic. They're mutations in some way. People, as I mentioned, experienced radiation sickness, often losing their hair. There's a form of, when someone experiences a burn and they're exposed to radiation in the process, often the scar material for the burn will expand and kind of form this very lumpy surface called a keloid scar. The keloid scars are unique to the radiation burn-related injuries. They tended to go away with time from people, but it was another mystery that people had to solve from a medical perspective. And then longer-term effects include various forms of cancer, leukemia, thyroid cancer, breast cancer, in victims who did survive the bombing but were exposed to radiation. And of course, in many cases, we see genetic effects passed on to children who were either in utero, so they were in their mother's womb when they were exposed to radiation, or even in children who were born after the bomb took place in the first place, or were actually conceived after the bomb took place, but their parents had been exposed to radiation poisoning at some point.